Hey everybody, Paul here for a quick video about how to solve for present value in our compound interest formula. Here we can see we have the equation 1728 is equal to present value times 1 plus 0.2 to the power of 3. Looking at this equation, we can see that there are a number of operations in it. There is a multiplication right here, and there is addition here, and there's a power right there, and to the power of 3. But the key thing about this problem is only one of those is an operation you're going to have to inverse. The other two you can actually do. All of the operations within this part of the equation you can actually simplify. So the first thing that we're going to do here is we're going to simplify 1 plus 0.2 to the power 3. We'll do it with the calculator. We go to the calculator. We do 1 plus 0.2. We do that to the power of 3, and that gives us 1.728, which means that this is really saying this is the equation 1728 is equal to present value times 1.728. So notice, like, we're not using subtraction here, and we're not using roots here because we don't have to undo those operations. We can actually simplify them. We only undo the operations we can't do because we can't do them. So that gives us this equation. We now just inverse this times 1.728 with division. We divide by 1.728. We divide by 1.728. On this side, it cancels out. These numbers look eerily similar, and we can see actually that when we do 1728 divided by 1.728, we get 1,000. So theoretically, 1,000 was the present value or the initial investment in this scenario. And just to check it, right, because we want to make sure that we are correct, we'll take this and we'll plug the entire thing back into the original expression. So we get 1,000 times 1 plus 0.2 to the power of 3, and that gives us 1728, which means that we have the following. We have the equation 1728 equals 1728, which check, boosh. That's a math term for when you get something correct, you say boosh, and we're done, and that's it. So we're still using inverse operations to solve, but we're simplifying before we do any solving, right? So a good little rule of thumb you maybe want to think of is like simplify as much as you can before inverse operations. Okay? That's it. I hope you guys are doing well. We miss you, and see you soon.